Adjacent angles. They are two angles that lie in the same plane. They have a common vertex and a common side, but no common interior points. So if we look at these, so for some examples, these angles would be adjacent. Basically, they're glued together at a side. And oops, that one's a little off. These angles would also be adjacent. Because they share this side. So angle 2 and angle 1 share this side, and here angle 2 and angle 1 share this middle side. Now, things that are not adjacent. If I were to take this angle and this angle and this angle, and it looks similar to number 1 and 2, but let's say I call this angle ABC, and I call this angle 3. ABC and 3 share this side BC, but they're not adjacent. Angle 3 is inside of angle ABC. So adjacent means next to one another, like glued together side by side, not one inside the other. So I would say oh, I'm taking up too much of my space. Hold on. Let me move that up here. Okay, another example would be if I had a line this could kind of look like it would be some sort of adjacent thing happening, but again, if we're talking about angle ABC and angle 3, they share this line in common, but they're not sharing an actual side. They're not stuck together next to each other. They're stuck to the same line. Yeah.
What's that dot, or what is that B?
That's a B. Yeah. So they're stuck to the same line, but adjacent angles are stuck to each other, side to side, not stuck to the same thing. Does that make sense? Yeah.
So the angles with B is the vertex.
Mm-hmm.
And like BA and BC, that's adjacent. And the one where the 3 is that not adjacent?
None of these. This ABC is not adjacent to 3. It's not AB or BA and BC are not adjacent to each other. They're just sides of an angle. So what you have is you have this angle ABC. So I'll just highlight it a little bit. And you have this angle 3.
What about that one right on the line?
Well, we weren't talking about. Now, if I wanted to talk about this angle here, this angle would be adjacent to this. These two angles would be adjacent to each other. But we weren't talking about that one. We were talking about these two. And so they're not adjacent. They're just stuck to the same line. Does that help? Now, a linear pair is another type of adjacent that happens. A linear pair is a pair of adjacent angles that form a straight line. So what'll happen is you have, so your first angle and then your second angle comes in, and they make a straight line, except that's not a straight line. Now it's a straight line. So angle 1 and 2 are adjacent, they connect, and then they form a straight line. So that's why they're called a linear pair. So they make a line. They can come close to making a line, but if it's not a perfectly straight line, they're not a linear pair.
As long as the line is straight.
It has to be a perfectly straight line, then it's a linear pair. Okay, so vertical lines or vertical angles are non-adjacent angles. Oh, shoot. I forgot to put that they share a vertex. So they're two non-adjacent angles that share a vertex. They're formed by two intersecting lines. So if I take a line and I take another line, angles 1 and angle 3 and angle 2 and angle 4 are vertical. So the angles across from each other. So 1 is vertical to 3 and 2 is vertical to 4. Now,
That's adjacent?
1 and 4 are adjacent, 4 and 3 are adjacent, 3 and 2 are adjacent, and 1 and 2 are adjacent. So the ones next to each other are adjacent, the ones across from each other are vertical. No, wrong way. These would not be an example of vertical angles. There are no vertical angles here because vertical angles only occur with two intersecting lines. So there have to be two straight lines and then you get vertical angles. I have some adjacent angles. This angle is adjacent to this one, which is adjacent to this one, which is adjacent to this one, but no verticals. Okay, so acute adjacent angles are two angles less than 90 degrees that are touching one another. So we have, this one is obviously less than 90. This one is obviously less than 90, but they're not touching one another. But which one do they touch that's less than 90? This one in the middle. So I could say angle OJN and NJM. I could come in and I could label these. And I could say angle 1 and angle 2, or angle 2 and angle 3. If I look, angle 3 and 4. Four and 5, 5 and 6. You know, I could, well, yeah, those are less than 90. So, you know, there's a bunch of different adjacent angles that are all acute here. You see what I mean? Basically, I can go around this whole thing and name any two that are next to each other, and they'll be adjacent. Obtuse vertical angles. Well, first we need to identify the straight lines. Straight line, not my highlighting, but the actual line underneath, straight line. So 5 and 2 are vertical, and then H, J, N, and K, J, M are vertical. Well, my obtuse ones are going to be the large ones. So it is going to be and KJ, M. A linear pair are any two angles that will make one of these straight lines. So I can use, if I want to use line KN, I can use angle 5 and then the whole angle here. I could use angle 1 and then this whole angle here. If I want to use the line HM, I can use angle 5 and then this whole angle, or I could use angle 3 and this whole angle. So I could say angle 1 and angle OJK. Those would make that straight line. I could say angle 5 and angle KJM. That would make this straight line. Or I could say angle 3 and angle LJH. So there's 4 different correct answers for this. Okay, if these big ones were my obtuse vertical angles, what are my acute vertical angles?
MJN
Uh-huh.
and HJK.
Or you could say angle 2 and angle 5. Well, we have that, we know what vertical angles are, but now we also have that vertical angles have a special property. They're congruent. So when I take a set of vertical angles, just pretend those lines are straight. This angle has the same measure as that angle, and this angle has the same measure as this angle. They're equal. Then we have another type of angle arrangement. If I have any two angles, and they add up to 90 degrees, they're complementary.
When there's two angles adding like
Any two angles, they can be adjacent to each other.
The keyboard to your computer screen would make a different angle, right? That's actually one of the questions on the one of the package you get.
You have supplementary, which is kind of along the same idea, except instead of being 90 degrees, they're 180. Okay, so supplementary angles are like complementary angles, except they add up to 180. So they can be attached to each other or they can be floating off in space. If they add up to 180 degrees, they're supplementary. And then a linear pair are two angles that make up a straight line. Two adjacent angles. Which we just already kind of talked about that, right? A linear pair are two adjacent angles that form a straight line. Linear pairs are supplementary. So they also equal 180 degrees. The difference between just general supplementary angle and a linear pair, adjacent. A linear pair has to be adjacent. Supplementary can be adjacent or they could be floating off in space. But they both add up to 180 degrees. Subtract. So if I say angle A is X, what would angle B be?
18.
X minus 18. Because they're going to be 18 different. Okay. So another way we could do it is we could draw a picture.
How would you know it would be X minus 18?
Because it said the difference was 18.
The two angles?
Yeah.
So you would now subtract 18 also from that?
You'd subtract 18 from one angle to get the other angle.
Okay.
Okay, so we could also draw a picture if you wanted to. You don't have to. But if we know they're supplementary, that means they're going to be a straight line. They're going to add up to 180. So I could call this one, call the bigger one X, so it's appropriate X. And if this one is 18 less, I could say that's X minus 18. So you don't have to draw a picture. You can kind of reason it out this way. You could try to draw a picture. Just remember that difference means subtract. And supplementary means equals 180. Okay? Or should I say the sum equals 180, so that's adding. So then to solve this, I'm going to say that X plus X minus 18 is equal to 180. Because the two angles, that's angle A, that's angle B. 2x minus 18 equals 180. 2x equals 198. No, wait. So divide by 2. And x is going to equal 96. Okay. 99. Not 96, 99. 2 goes into 19 9 times, which is 18 with 1 left over, which is another 18. So it's 99, not 96. So if I divided correctly, it would have been right the first time. Okay, so that's this one. This one's 99 degrees. The other one is x minus 18. So I have 99 minus 18, which is 81. So that's 81 degrees. And I can double check it and make sure it works, because I can try do 99 and 81 add up to 180. Yes, they do. So it's good. We're finding complementary angles. So complementary means they have a sum of 90 degrees. And the measure of the larger is 12 more than twice the measure of the smaller. Okay, so that's 12 plus 2 times.
Well, okay, when it says always more than.
And more than gives me the plus. It's the plus. So 12 more than 2 times the smaller one. So this is the large. That's the large, and that makes this the small.
So then I would have 2 of those 12 plus 2x, right? Or
Well, x is the small angle. Here, hold on, let me do this. We have, in this case, we have a small and a large. So we have a small and a large, and they're adding up to 90. Okay, so the large one is 12 more than twice the small one. So 12 plus 2 times the small one. That's this one. And then the small one is this little x right there. So that's x.
Can you still write it as 2x plus 12?
Yeah, you can write it as 2x plus 12. Okay. Subtract 12 from both sides, and I'm going to get 78. Divide by 3, and I'm going to get 26. 26. So the small angle is 26 degrees. Now there are two ways I can figure out the large angle. I can either plug it in to my 2x plus 12, or 12 plus 2x, however you wanted to do it. And that's 52 plus 12, so 64. Or I could just say I know they're going to add up to 90, so I can do 90 minus 26, and that's 64.
So, the smaller angle is 64?
No, the small
Okay.
angle is 26, and then the large angle is 64. So here I had 99 and 81. Here I have 26 and 64. So any line, segment, or ray intersects at 90 degrees is perpendicular. The symbol from perpendicular is an upside down capital T. Now you never have to write the word again. Okay. Perpendicular lines intersect to form 4 right angles. Perpendicular lines intersect to form congruent adjacent angles, because they're all 90 degrees, so everything's congruent. Okay, then we have segments and rays. Can be perpendicular to lines or segments and rays. And the right angle symbol, which is this little box right here, is also a symbol for perpendicular. Okay. And if you wanted to talk about perpendicular lines symbolically, you would say line AB is perpendicular to line CD. So this is symbols. So some examples, we're going to find X and Y so that PR and SQ are perpendicular. Well, if they're perpendicular, that means these are going to be right angles. Okay. So 4y minus 2 is going to be 90 degrees. Okay. So I'm going to add 2 to both sides.
Wait, what did you say with those two? They're perpendicular?
We want the lines to be perpendicular. So we're looking at lines SQ and PR. So we want these two lines to be perpendicular to each other. So that makes these right angles.
Okay.
So that's why they're 90 degrees. The one angle here only has y's in it, 4y minus 2. And it is 90 degrees, so I just set it equal to 90 degrees, and then I solve it. degrees. Y just equals 46. Now on the x's, I have two angles that are adding up to make the 90. So this plus this equals 90. Does that make sense? So I'm going to have to add those together. So 7x is going to equal 84. So x is going to equal 12. Okay. A non-picture example would be if angle D is 3x plus 12 and I want to make it a right angle, I have to set that equal to 90. And find x. So subtract my 12